Hello everyone, this is the third video for Unit 4. This video will cover factoring quadratics. So as you can see, there is 4 pre-class assignments to be done. 3 and 4, factor by grouping. These are to be done by 7/18 at midnight. Before we get into factoring, polynomials that cannot be factored are prime, because they can't be broken down into any factor that's not itself or 1, the same as the definition of a prime number. Factoring can be checked by distributing, basically by multiplying back out the problem to get what you started with. Now, what we're going to do with these quadratics is we are going to factor by what's called the sum product with grouping method. The implied lead coefficient, first of all, would be the A coefficient of this term. In this case, it is 1. It's implied because it's not written. Your sum is always whatever the B term is. In this case, your B term is 9. And your product is always A times C, which is 1 times 14. And remember, I'm getting this number, these numbers, A, B, and C, from the general form of a quadratic that we discussed the very first video of this unit. So here's the general form of a quadratic, and A, B, and C are the specific coefficients. Alright, so let's jump back to the factoring. So now, our sum is 9 and our product is 14. We need to ask ourselves, what two numbers multiply to get 14 and add to get 9? So let's do the factors. Let's do 1 times 14, 2 times 7, 3, there's nothing times 3, nothing times 4, nothing times 5. So those are the only two sets of factors. 1 plus 14 is 15, that doesn't add to 9, but notice 2 and 7 do add to 9. 2 plus 7 is 9. So what we do, since our implied lead coefficient is 1, we can jump straight to our factor pairs, where x squared plus 9x plus 14 equals x plus 2 times x plus 7. Now to check that, you would multiply back out this these two binomials. So you'd have to do x times x, which is x squared, and then x times 7, which is 7x, and then 2 times x, which is 2x, and then 2 times 7, which is 14. And you notice that equals x squared plus 9x plus 14. So it checks out. So here are our factor pairs, 2 and 7. Now what happens when the lead coefficient is not 1? When it's something else, like this problem where it's 6. Well, you have to, you still do it the same way, but you have one more step that you have to do. First thing when you factor polynomials is you look for a greatest common factor. You look for a GCF. In this case, this number doesn't involve x, so there's no x as a common factor. And these are all relatively prime, 6, 7, and 5. They all don't have something in common, so there is no GCF. So there's none. That's always the first step. So our sum, our B term is negative 7, and our product is 6 times negative 5, which is negative 30. Now you notice this factor is negative, our product's negative, and our sum is negative. So one of our numbers here has to be negative. So 1 times negative 30, that gives us negative 30, but when I combine them, that gives me negative 29, so that's not right. 2 times negative 15, I multiply them, I get negative 30. When I combine them, I get negative 13, so that's not quite right. What about 3 times negative 10? When I multiply 3 times negative 10, I get negative 30. And then when I combine them, 3 minus 10, I get negative 7. So this is my factor pairs, and my signs are correct. If this 7 was positive, and the 30 stayed negative, this would be negative 3 and positive 10, so that when you combine them, you get positive 7. So now there's one more step we need to do. We can't jump straight into our factor pairs. It's not just x plus 3 and x minus 10. We have to do what's called the factor by grouping. So I'm going to take 6x squared minus 7x minus 5. And what I'm going to do is I'm going to split this middle term to where it's some combination of 3x minus 10x or minus 10x plus 3x. 6x squared something, then over here is minus 5. So I know 10 and 5 group together pretty nicely, and 3 and 6. So I'm going to write plus 3x minus 10x. Like so. So all I've done is I've taken that negative 7x and I've split it into these two factor pairs. So now what I do is called factor by grouping. So I'm going to group those together. What does 6x squared and 3x have in common? Well, they both have a 3x in common. If you don't see that, the pre-class assignments, the distributive property factoring out of GCF, these pre-class assignments really help you find these factors of these problems. So when I take 3x out of here, I'm left with 2x. And I can check myself by saying 3x times 2x is 6x squared. Here when I factor out a 3x, I have to have a placeholder that will be a 1. So that when I do 3x times 1, I get 3x. Both of these terms involve a minus, and over here, both of these are positive. So what I want to do is somehow come up with a 2x plus 1. So I'm going to want to take the negative out along with 5. They both have a 5 in common. So over here, when I take out a negative 5, I'm left with 2x, and over here, I'm left with plus 1. Then if you look at these two sets of terms, what do they have in common? Well, they have 2x plus 1 in common. And what's left? 3x minus 5. And there it is. So this one we had an extra step where we had to factor by grouping because our lead coefficient wasn't 1. Let's look at this middle one right here on the page. GCF. Does this have, this polynomial, is there something in common amongst all three terms? Well, this has a y cubed, this has a y to the fourth, this has a y to the fifth. So all three of these have a y cubed in common. This one has a 3, this one has a 9, so they both have 3 in common, and this one has a 54, which also has 3 in common. So we have a GCF of 3y cubed. When I factor that out, I'm left with y squared, because when I multiply 3y cubed and y squared, I'm left with 3y to the fifth, minus 3y. So when I multiply 3y cubed and negative 3y, I have negative 9y to the fourth, because 3 times negative 3 is negative 9. Y cubed times y is y to the fourth. Minus 54 divided by 3 is 18. So now throughout the problem, I'm going to keep this GCF kind of going along with it and then have my factor pair over here. So my sum is negative 3 and my product is 1 and negative 18 to give me negative 18. What two numbers multiply to get negative 18 and combine to get negative 3? Well, that's going to be negative 6 times 3. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So now, since over here, since my lead coefficient is 1, I can jump straight to my factor pair. So my answer is 3y cubed, y minus 6, y plus 3. And I could have wrote this as y plus 3, y minus 6. It doesn't matter what order. What does matter is the sign. The negative has to be on the 6 and the positive has to be on the 3. Alright guys, that's basically the gist of factoring. So here at the top of page 15, it gives to factor a polynomial, your first step is always to find a GCF. After you found a GCF, if one exists, then if it's a 4-term polynomial, you factor by grouping. Right away. And if it's a 3 term, you use the sum product table. So what I'm going to do is I'm going to find a 4 term polynomial right here. So here we have x cubed minus 4x squared plus 3x minus 12. This one you cannot use sum product table. You have to do factor by grouping. It's a 4 term polynomial. So you have to do factor by grouping. Just like the middle step when you use the sum product table. So what I'm going to do is I'm going to put these two together, and then I'm going to put these two together. So what do x cubed and negative 4x squared have in common? Well, they both have an x squared in common. I'm left with x minus 4. Over here, 3x and negative 12, what do they have in common? They both have a 3, and I'm left with x minus 4. So now I have the quantity x minus 4 times x squared plus 3. Now this says x squared plus 3. Let's see if this factors. This is a 3-term polynomial, even though you don't see the middle one, because the middle term is plus 0x plus 3. So using our sum product table, our sum is 0 and our product is positive 3. Is there two values that when multiplied together give us positive 3 and sum to 0? No. It does not factor any further than this. So that's the correct answer, and you could actually write it shorthand. I would accept x squared plus 0x plus 3, or just x squared plus 3. Let's look at another type, which are called perfect square trinomials. And I really want to go into here. So special forms, difference of squares. All these other ones you do the same, these you do the same sum product method. So here our sum would be 12 and our product would be 9 times 4, which is 36. So it would be 6 times 6 and go from there. Break this down into 6x and 6x, so you have 9x squared plus 6x plus 6x plus 4, and then factor by grouping. Let's look at these perfect square. Special forms, difference of squares. So here's our polynomial. The middle term isn't written in here, but it's 0, so we could write it out as 4x squared plus 0x minus 25. So our sum here is 0, and our product is 4 times negative 25, which is negative 100. So what two numbers multiply to get negative 100 and add to get 0? Well, that's 10 and negative 10. When this value is negative, it is factorable. So now this graph, this thing, we could split our 0x into 4x squared plus 10x minus 10x minus 25, and then factor by grouping. What do these two have in common? Well, they have 2x. So I'm left with 2x plus 5. And over here, these have a minus 5 in common, so I'm left with 2x plus 5. Because negative 5 times 2x is negative 10x, negative 5 times positive 5 is negative 25. Then that gives me the 2x plus 5, 2x minus 5. Notice that this is difference of squares. When I have a perfect square minus another perfect square, it will always be of this form. So another example is x squared minus 81 will be x plus 9, x minus 9. Because now my negative 9x and my positive 9x end up canceling out, and I'm just left with x squared minus 81. Conversely, this is not the difference of squares. This is the sum of squares. So our sum would be 0 and our product would be positive 100. There's no two numbers that multiply to get a positive number and combine to get 0. Because these numbers would either have to be 10 times 10. That doesn't get 0. and negative 10 times negative 10, when I add that together, I do not get 0. So this is a prime polynomial. Notice it says difference of squares, not sum of squares. And from there, that is basically factoring. Let me do one more example. Let's do, so this one, this is difference of squares, z squared minus 49. So this is going to be z plus 7, z minus 7. This one, you would do group factor by grouping. You get x squared equals x plus 2. Factor out a negative 2, you get x plus 2. You get x squared minus 2, x plus 2, which is fine for the answer. And this is not a perfect square, so we don't want you to factor that any further. 2 is not a perfect square. This one, our sum is 7, our product is negative 30, 15 times negative 2. Let's go positive 10 times negative 3. And go from there. So you end up having 15x squared plus 10x minus 3x minus 2, and then factor by grouping. So you get, both of these have a 5 in common and an x, so we'll pull out 5x, so then you're left with 3x plus 2. And over here I'm just going to pull out a negative 1 so that I get 3x plus 2. My answer is 3x plus 2 times 5x minus 1. Alright class, so this video covers both of these homework assignments, factoring 1 and factoring 2. Your next videos will cover the last few post-class assignments. So we have to cover zero factor property, the explore intercepts and symmetry, applications, and we have some other stuff before the quadratic formula. Then we'll talk about inverses and using Excel. So we're getting close to the end. The exam for Unit 4 is next Sunday. Next Sunday. Not the 13th, but the 20th. All right, thank you everyone, and have a wonderful day.